We're going to introduce, we call it arithmetic. It does look like arithmetic. And geometric sequences. So we're going to start off and basically get out your calculator already and get out your formula sheet. If you'll look on the front of your formula sheet, you will see these formulas. Now, they have little different notations, but they just change them in and out. So I'll show you the difference here in a little bit. But look on the front of your formula sheet. You should see a whole bunch of things for arithmetic and geometric. And so we're going to, this next section, I doubt will be done by the time we leave for fall break. But it does take a pretty good bit of time to get through it, to get through everything, every part of it. All right, so with an arithmetic sequence, this is a sequence of terms that have a common difference between them, okay? And when I'm talking about difference, so let's do this, 2, 5, 8, 11, dot, dot, dot. Now, sometimes this is really easy to see. This is a change of what? 3. The common difference is 3. I always do right minus left, just in case there's any confusion. If it's not real obvious, you always want to do right minus left. So 11 minus 8, always check all of these because it may or may not be either one of them. It could be geometric, it could be arithmetic, it might be neither. But check all of them. So 11 minus 8 is 3, 8 minus 5 is 3, 5 minus 2 is 3. Now, the formula for this, now if you'll look, you don't see a T sub n on your formula sheet. They use T sub n here. Our formula sheet uses A sub n. It's the same thing. So this is like for which term? Okay, an arithmetic term. The formula is A plus n minus 1d. So, pretty much, you're not going to see T sub n except for on this worksheet. We're going to mostly use A sub n right here. Now, let me define this for you, and you want to write these down. A, that is the first term in the sequence. N is the number of terms in the sequence. And D is the common difference. Okay? So let's go over to the next side of the line. It says a geometric sequence is a sequence of terms that have a common ratio. Now, obviously, we can look at this and we know that these are not going down by the same amount, right? Or going up by the same amount. That's very obvious. So the next thing we want to check is you always do right divided by left. And once again, you kind of want to check all terms. And sometimes if I really can't keep up with it, I'll write it at the top. So 24 divided by 12 is 2. 12 divided by 6 is 2. 6 divided by 3 is 2. So the ratio on this one is 2. Now the formula for it, again, they do T sub n. We do A sub n. A times R to the n minus 1. And A is still the first term, n is still the number of terms, R is the common ratio. Those are not squares, just make sure y'all know that. That's common difference. Common ratio. Okay, so let's look at question number 1, A, B, C, D, E, and F. So they want us to decide whether it's arithmetic, geometric, or none. And then if it's arithmetic, what is the common difference? If it's geometric, what is the common ratio? Of course, if it's none, it doesn't have anything. So look at the first one. The first thing I would do is I'd always check for arithmetic. Do right minus left. Check for a common difference first. Did it go up or down by the same thing? Okay, so that means it's what? Arithmetic. And what is its common difference? 6. All right, let's check B. So 17 minus 11 is 6, but 11 minus 6 is 5. That doesn't have the same difference. So then we can check division. 17 divided by 11, and then 11 divided by 6, and see if they have the same common ratio. So what would the answer to that one be? Neither. All right, go ahead and do C through F for me. Done with those. Okay, so C, what did we get for C? Geometric or arithmetic?
Geometric.
All right, so I'm just putting GO, and what was the ratio?
7.
7. Remember, you've got to do right divided by left or you'll mess it up. And the reason I'm doing that is because it's multiplying as it goes on out. So the opposite of multiplication is division. So I can find out what it's multiplying by actually dividing. D. Geometric, and its common ratio? Yep, 0.5 or 1/2, doesn't matter. E. Arithmetic. Yeah, it's a little hard to say. Arithmetic, I'll take that. What is the common difference? 15. And the last one? Geometric, and its ratio is negative 3. All right, so any problems or questions with coming up, whether it's arithmetic or geometric? All right, let's look at number 2A. So what they have done now is they're telling us that these are arithmetic sequences, so circle that for me. They want us to find the A, the D, and the formula for the general term, which is your A sub n. So when they're asking about the general term, they're wanting the A sub n. So go ahead for all of A, B, and C. Don't do the general term yet, but list me the A and the D for each one of them. Y'all can do those. We'll talk about the general term in a minute. Okay, the A's are really easy. They're the first term. Negative 10, 10, and 36. To get the common difference, right minus left, so 6, negative 2, and negative 5, I believe. Okay, so now they want us to write the formula. So I'm going to, y'all stop and just watch me and then try to decide which one that you want to do. I have a couple of methods to get to this formula, this A sub n formula. So our difference here was 6. Now I don't think we covered this in IGSY 1. This would have come in IGSY 2. So the A sub n formula, I always look at it, because this is linear. Y'all realize that this is like basically a straight line. So I'm writing y equals mx plus b, okay, this being the slope. So remember, this is n equals 1, 2, 3, 4, 5. So you always take the difference. This is the easy route. Take the difference, 6, and put it by the n. Okay? Now, if I was going to pass through the y-intercept, y equals mx plus b, what would this have to be? What would the x have to be on the y-intercept? 0. So if the x is 0, then that gives me the y-intercept. So one of the things that I can do is I can take this and go back to n equals 0. Okay, so what would this have to be so that when I add 6, it becomes negative 10? Negative 16. That's the formula. Now I'm going to show you 2 other ways to get it. So if you didn't understand that, you can always take it to 0. This is your first term. So, like, what would this have to be so that when I added 6, I got negative 10? Have to be negative 16. Now, let's look at it this way. This is option number 2. So 6n plus something equals negative 10. Okay, so I've got 6n plus some number x is going to equal negative 10. And I pick negative 10 when my n is what? 1. So in place of n right here, if I'm going to use the first term, I can use any term I want to if it's linear. 6 times 1, what would that x have to be? Negative 16. Questions so far on either one of those? I'm fixing to show you a third method. So you can take it back to 0. You can plug in the n is 1 plus something would equal negative 10. That gives you the formula. And here's the last one. Use the 1 at the top. A sub n equals A. What is my A? Negative 10 plus n minus 1 times 6. And we need to simplify that. Negative 10 plus 6n minus 6. A sub n is 6n minus 16. Now tell me which method you like best. Like the first one? Like the formula? Formula's going to be on your formula sheet every time. Okay? Pick one that you like. It doesn't matter to me, but you got 3 options here. You can take it back to 0. You can solve for the unknown by substituting in a value of n and seeing the output, or you can use the formula. Doesn't matter. So try B and C any way you want to and see if you can come up with the A sub n formula. There are your 2 formulas. Now back in Easy 2, they called this the nth term. And I remember the first time, well, every time I teach it, when kids first see it, they think it means the next term. But it's really the formula for, how you're going to get n is when n is 1, 2, 3. So this is finding a certain term. So are there any questions? I don't care how you arrived. Did anybody need me to go over? Always a good check is that your D better be by your N. So that's always a good check. You might miss these, but that's a good check. Are we okay on those? All right, let's flip it over and look at the next question. It wants you to still deal with 2C. Now, they ask you to find the T sub 7 and the T sub 20. So what in the world are they asking for? The 7th term and the 20th term. Guys, I'm not a detail-oriented person. I'm just not. But if you look back at the formula, didn't they have T sub n equals? And so if you look back, they're basically telling you that this is your n. So n is 7 here, and n is 20. So go back and use the 2c to find the 7th term and the 20th term. Oh, it's supposed to be 20. Thank you. Now this one's not Cambridge, so all of ours will say A sub 7 or A sub 20. So your T sub 7 or your A sub 7 term was 6, which that you could just probably keep doing your difference that far. But if they ask you for the 199th or the 202nd, you don't want to do that on your piece of paper. And the 20th is negative 59. Are we okay? All right, now we want to do geometric. So, starting with number 4, it's a geometric sequence. They want you to find A and R and then state the general term, the formula for the general term. So you're going to do your A, you're going to do your R, and you're going to do your A sub n. Okay? The A sub n is on the front page. It's A times R raised to the n minus 1. All right, y'all can stop and get your phones out. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Very good. All right, finish up those 3 if you have not. Go and give these. They're pretty easy. 1, 12, and 9 are your A's. Then your ratio 3, 1/2 or 0.5. I don't care how you note that. And negative 1/3. Now your A sub n, 1 times 3 to the n minus 1.
That would be the final.
This one would be 12 times 1/2 to the n minus 1. Now, let me ask you this. Let me write this up here, then I want you to answer something for me. Can I simplify that to this? I'm seeing nods and I'm seeing shakes.
You have to do exponents first.
That's right. Please excuse, my dear. So, sometimes we forget fundamentals when we're working a problem quickly and we think that we need to simplify and we kind of get ahead of ourselves, and it's real easy to forget our fundamentals, but you do not want to multiply those because exponents would come first. And so this would be 9 times negative 1/3 to the n minus 1. All right, so now that is actually 4a. I believe that was written over on your sheet. So you're going to use 4a at the top and find me the t sub 4 value and the t sub 12 value. It's 3 to the 11th power. So it's going up exponentially. Okay, so we know that Cambridge is never going to be that straightforward. We wish, but it's just not going to happen. So looking at the one at the bottom starts to show you a little bit about what could be done with these. It says find the number of terms. Circle that phrase. And I laugh because I won't tell somebody, but what am I looking for? The n. Somebody last period said the number of terms.
I just can't.
Huh? I know, and you know, and sometimes when you have time and you want to get some points, just go for that. You know, they may not give you all points because they want to see certain things written down, but hey, you know, get points where you can get points. Well, let me go back and show you exactly. So when I'm doing an arithmetic, and they said that these are arithmetics, right? I need to find an A. I need to have a D, I need to have an N, and I need to have an A sub N. So if you look at the formula, it's A sub N equals A plus N minus 1D, right? And that's the formula. So those are my 4 variables. I've got to have 3 of the 4. Got to. I have an A, right? 2. I have a D, 3. The N is what I'm looking for, so what in the world is the A sub N? That's the tricky part. Okay, your A sub N, remember what I told y'all, now was this not the formula that we basically used for finding the 7th term? The 12th term, the 20th term, so your A sub N, would be the term of this. Like when I put N is whatever, I'm going to get 299. So this is the last one. That is the very last number in the sequence. I want to know basically what that number is, what n number that is. So this is n equals 1, 2, 3, dot, 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 a sub n. Because if I know the n, then I should be able to spit out that the a sub n is 299. So this is your a sub n. Okay?
Will you put it in the problem and then equal it to 299?
Yes.
Oh.
Yes. So in this problem, if you have this right here, so like if they told you that this was, like if they asked you for the 10th term, you put 10 in here and you put everything else and you'd find your a sub 10, right? And that would be a number. So what we're doing is this time we're just kind of reversing it. So what they have done is they've given us the a sub n, 299. They want to know how many terms are in that sequence. So I know that's number 1, number 2, number 3, all the way to I don't know. So you would put 299 in for a sub n because we're going to find the n number that matches that. Okay, my a is 2, the n I don't know, my d is 3. So then you have to be sure and distribute that part right there. And so that becomes 300 equals 3n. So 299 is the 100th term. Now, most of the time we have plenty of time left on these tests in May that you could have probably written it all out and come up. I'd get some points. I'd sit there and get some points rather than take a nap. I mean, what's a nap going to do for you? So you could do something like that. But remember, everything hinges off of that formula. So let's look at the next one. See if y'all can figure out the next one now that you know this one. Okay? Everybody's okay? So you're going to see that one reason why this unit takes so long is that these numbers and these formulas can be manipulated in a lot of different ways. Okay? So one thing that I want to start doing, and I want to start doing it consistently because they're this is part of our, as a teacher, this is something that we get graded on, so to speak, and one of the things that I got feedback from from my evaluation is to do a takeaway or most important points. Okay, so I want to try to start summarizing. So takeaways from the lesson. Okay, or I might do most important MIPs, most important points. Okay, so first of all, we've got two different types of sequences. Tell me what they are. Okay, what's the difference? All right, which one? Okay, common difference. And how did we come up with that? Right minus left. And geometric is common ratio. And how did we come up with that? Right divided by left. Okay, sometimes this is a thing that people just see. Some people have that ability. I do not. They can look at a series or a sequence and they know exactly what's going on. It's a little more challenging for me, and so if I can come up with processes that help you along the way or steps, that's what I'm going to try to do. Because some people can look and go, oh, you just add 2 every time, or you just multiply by 6. Sometimes it's not as easy to see, especially with bigger numbers. So keep those in mind. All right, the formula for an arithmetic, you have got it on your formula sheet. Also, for geometric, use these. Every quiz, every test, everything. Because if you get used to using them now, you will use them in May. If you don't use them now, that thing won't come out of your packet in May. All right. Anything else we want to add to the most important points or the takeaways for today? Use those formulas. Okay, so I think we have a quiz on Thursday.